So here we're just factoring. Part A is really a no-brainer. Okay, we've got x squared plus 5x minus 24. Again, always check, is there a common factor? Is there something you can pull out of each one of them?
There is 1.
You can pull out a 1. You could pull out lots of 1s over and over again if you wanted to make this question take a long time. That is true, but it's not a helpful thing. So no, there's not a common factor bigger than 1 in this case. So then we set it up. Again, we look at our first ones, look at our last ones. To get our first ones, what are the only possibilities? X and x. I would start there because it's basically it has only one possibility. The 24 has more possibilities. So this is where we can take out that other pen again. Of course, there's some bad choices. Outside and inside, does 24 and 1 ever make 5? I'd hope you wouldn't go to that one as your first option. Okay? These ones with x's at the beginning, you can start to see a little bit quicker. Okay, 6 and 4? No. 8 and 3? Yes. So write your 8, write your 3, then check. I need it to be negative 24 and a positive 5, so my 8 has to be positive. My outside, which is my 3, has to be negative, and that will give me plus 5x. Now, when we get to b, it looks complicated. There are two options for b. Option 1 is to actually simplify everything, because you can square x minus 6 and do x minus 6 and x minus 6. Square that out, multiply the 2 by everything, get a whole bunch of stuff there. Distribute the 10 and go 10x minus 60. And then minus 48. Combine all your like terms, and you will get a new trinomial, which you can try to factor. Okay? The easier way is to recognize that this has the same form as A. It has the same form. That's an M with 4 lumps. That's a crazy looking M. Sorry about that. Same form as A. It is something squared plus something times x minus something. In fact, I'll make it look like A by picking a new letter other than x. What letter would you like to use? Q. Q's are fun. Nice. So we're going to make Q equal to x minus 6 temporarily. Because that'll change this question, and all of a sudden it's going to look like this. 2q squared plus 10q minus 48. Doesn't that look a lot easier to factor than what we had before? And by substituting that in, now we can check. Is there a common factor? 2. So we'll take that out to start with, leaving us with q squared plus 5q minus 24. Ooh, that's the same thing we had for part A, right? We've already factored that. That just becomes bracket, QQ, and 24 and 5 you already know is 8 and 3. The 8 had to be positive, the 3 had to be negative. Now we temporarily made it q so we could factor here. Now we can substitute back. And wherever there's a q, I'm going to write in brackets x minus 6. We still have the plus 8. And here, x minus 6, and we still have the minus 3. If I look inside the first set of brackets, can I simplify anything in there? Are there any like terms? Minus 6 and 8 will leave me with x plus 2. Minus 6 and minus 3 will leave me with x minus 9. And now we factored it completely. Part C, can I scroll up? Is everybody ready? So before you dive into a question, you want to take the time to look at it and say, does it look like a trinomial even though it's got a whole bunch of other stuff in there? Yeah. So then you might use this strategy to substitute. What letter would you like to use this time?
How about
C came before K, so I'll go C. We'll let C equal 2x plus 5. Temporarily again, so now instead of 2x plus 5 squared, I'd have 3c squared plus 10c minus 8. Is there a common factor? No. So we set up our brackets. If I look at my first, right, and I look at my last, and it may have been in grade 10 that you, whenever the first one wasn't just an x squared, you gave up on it. Maybe that was your strategy in grade 10. These ones are too hard to factor, so I give up on them. And now if you think about the possibilities for 3c squared, its prime number, there's only one possibility. It has to be 3c and c. It's your only possibility. Okay? Now for the 8, again, if you can't figure it out right away, the best strategy is just to try one. So if the mental math is too much, try one. Try 4 and, well, that's going to work right away. I want to pick something that didn't work. Let's see. Let's try 8 and 1 here. You just try one. What's my outside going to be? 24. My inside? 1. That doesn't work. Okay? The biggest mistake that people make in these ones is they don't think about the 3 in front. Like you think 2 and 4 never makes 10, 1 and 8 never makes 10, maybe this one can't be done. But you have to remember that you're going to include that first one. This is actually a tough one. Okay? And I'll show you why it's tough. This is one of the hardest questions to factor because if I would do this, and I'm not going to make this disappear right away, 4 and 2. What's my outside? 6. What's my inside? 4. 6 and 4 makes 10. You get excited, right? Yeah, got it. Okay? Now, this is why I always get you to check in the end because there's a few things that when you factor, there are some answers that'll give you the right number but won't be the right answer. Watch what happens. When I do this, I'm going to need to make one positive and one negative to get the negative 8, right? So let's say I make the 4 positive and the 2 negative. Now, what's my outside? Negative 6. What's my inside? Positive 4. Does that make 10? No. So you think, oh, I got it wrong. I've got to go positive here and here. My outside now is 6. My inside is negative 4. That gives me 2. So it's not 4 and 2. Even though 4 and 2 gives us 10, we'll have to find something else that gives us 10. If you do 2 here and 4 here, now my outside is 12 and my inside is 2. And that makes 10 again. And if I make my outside positive and my inside negative, I'll get positive 12 minus 2, which gives me 10. Some people look at this last one And if it's negative, it's going to tell you that you have to subtract. If the last one's positive, it's going to tell you you need to add to check. And so because this last one's negative, we have to subtract to check. And that's why we needed 12 minus 2 to make 10. And that's why 6 and 4, which makes 10 when you add, didn't work. But there's a couple of factoring ones out there like this where you have to be careful because you might get the 10, but it may not work. Now we temporarily made C something, so now we have to substitute back. Substitute. So we're going to get 3, and instead of C, I can now write 2x plus 5 minus 2, bracket, and then bracket, and then instead of C, 2x plus 5 plus 4. Check in those brackets. Is there anything we can simplify? Well, this 3 here would get distributed. So then I would have 6x plus 15, still minus 2. And here, 2x plus 9. And there's still some things that can be put together. 6x plus 13, 2x plus 9. Ugh. Any common factors in the end? Nope. So we have this factored completely. This one, had you done the longer way and multiplied it out completely, if you had multiplied it out completely, this thing would have looked like this originally. 12x squared, 26 plus 54 plus 80x plus 117. And that's about as nasty a factoring one as working backwards. That's like mixing sand and dirt almost and trying to separate it afterwards. That would be a very hard one to factor because this isn't a prime number, 12 isn't a prime number, so it would take a long time. Okay, the questions you can do after example 3 are 15 and 16.